Hi everyone, today we are going to discuss about the topic called hashing. So let's say I have a sender here and the receiver here. So I wanted to send a confidential information, a secret information from a sender to a receiver. So what can I do? So I can hash the message and I can send this information to receiver. What if there is a man in the middle attacker and he changed the message and he deliberately changed the message and sent it to receiver? So receiver doesn't know here whether the message came from the original or the genuine sender. So that is a problem. So there is a problem here. So that how to overcome it, we'll see. I'll tell you that later. But first, understand how hashing works, and we'll see how to overcome the issues with the hashing. So, let's say there is a message, hi, hello, how are you? That's the message, hi, hello, how are you? So that message, I am using a SHA as a hashing algorithm. So I put the hi, hello, how are you message into a SHA algorithm. And this algorithm worked and computed me a output which looks like 01100. Okay, so this 01100 is called a ICV, integrity check value. Okay, so integrity check value. By seeing this 01100 or the hash value, can you identify what is the actual message? No, right? The actual message what we discussed is hi, hello, how are you? But by seeing this 01100, let's say there is a long message 01100 hash ampersand. So there is a long message. By seeing this value, can you identify the actual what is the actual message? No, right? We cannot identify. Hashing is used only to verify whether the message has integrity or not, whether it is compromised or not. So how we will verify, that we'll see. So instead of the message, what I'll take here, I'll take an example of a coffee beans. It helps you to understand in a better way. So I have took the message as a coffee beans, and this coffee beans I have put in a grinder, in a mixture, to mix this coffee beans to a powder, and the output is obviously a coffee powder. So this coffee powder, can you put back in the same function, put back in the same mixie or a grinder, and can you make a coffee beans again? No, right? By using any technology, any kind of means, you cannot make coffee beans from the powder, right? So what my intention here to explain is, hashing function is one way. You cannot do the other way. Meaning, you should not confuse with hashing and encryption decryption. Encryption decryption, with the help of the keys, public keys and the private keys, you can encrypt and you can decrypt with the keys, and you can know the actual data. But here, once you put the message in a SHA, in a hashing algorithm, you will get the hash value, which we call it as a ICV. By seeing this hash value, you cannot, first of all, you cannot understand what the actual message is, or you cannot convert that into an actual message. Okay, so by doing the reverse process with the same hash value, you cannot get the actual message. That's why I took the coffee beans example here. Okay, so I have sent a message here to the receiver, and the receiver also does the same process. So he also does the same hashing process, he will do, and he compares the ICV value, and if the ICV value is matched, it means the message is not compromised, integrity is achieved. That's what we all learned in the textbooks. Hashing is used for integrity. The problem here is the receiver doesn't know whether this message came from the actual sender, the genuine sender or not. So let me tell you one more example for the better understanding. Have you ever downloaded the image file from the Cisco website, and have you seen this? I'm sorry if this message is a bit blurred, but I hope you can understand. It's a description, it's a file name, size, MD5 Checksum, SHA-512 Checksum. So if you download it, you can see here, this is the Cisco image file name, this is the size, this is the release date, and he's asking you to download here. Okay, once you download, before download, what he's saying, this is the MD5 checksum value. This entire value is the MD5 checksum value, and this is the SHA-512 checksum value. Okay, so he has given, the Cisco has already given for this file, these are the MD5 checksum values and SHA-512 checksum values. So what is your job now? Once you download the file, instead of installing this image file directly into your router, first you need to verify the MD5 checksum. Correct? Many of you might have done this. Okay, so how you do that? So here you do verify /MD5 disk, and you will give the file name, and once the entire process is done, you can see here, once the entire process is done, you will get the MD5 checksum value. And if this MD5 checksum value is matching to the Cisco what they have given, then the integrity is achieved, right? Integrity is achieved. If it is not matching, what you will do? What is that meaning? This image file someone altered and kept in the Cisco website, and if you install this image in your router, you know what happens next. So that's the reason you will verify first with the MD5 value. Okay, so that is the problem here. So here the receiver does not know whether the message is coming from the actual source, actual sender or not. So that's the reason we have a new technology called HMAC, hash based message authentication code. HMAC, hash based message authentication code. We'll discuss this in the next video. In detail I'll explain you in the next video. I hope I have clarified you this. If not, please revise again and you can comment me. Thank you for watching. Have a good day.